going to have two parts to it. The first part, we're going to look at the experiment on extracting clove oil from cloves using a process called steam distillation. And then the second part, we're going to look at isolation of eugenol from an emulsion of clove oil and water by a process called liquid-liquid extraction. So our learning intention is to isolate eugenol from cloves via steam distillation. So our first experiment that we'll look at is steam distillation and how we can extract clove oil from cloves by this process. But before we start, it's important to do our definition of what steam distillation is. So steam distillation, it's a separation process used to isolate compounds at temperatures below their decomposition temperatures. It's carried out by bubbling steam through the material and distilling off the immiscible liquids. It's also important to know the principle of steam distillation, and the principle of steam distillation is that a mixture of two immiscible liquids boils at a temperature below that of the boiling point of each of the liquids. The hot mixture of water vapour from the steam and the oil from the plant or from the cloves that we're going to use is passed through a condenser, and the distillate is collected. And that distillate that is collected is a mixture of oil and water. And this mixture of oil and water that we collect has a name, and it's called an emulsion. So your definition of an emulsion is a dispersion of small droplets of one liquid in another liquid which it is not soluble. And as you can see from the diagram here, the blue represents our water or the steam, and the little yellow dots represents the clove oil that will be extracted from the cloves. So this here is just a simple setup of what steam distillation would look like. So as you can see here, we have our steam generator, and connected to that then, along here we have got a steam trap. It's not shown in this picture here, but a steam trap will be put in along here. It then flows into our flask that has cloves in it, and the cloves are bubbled, and the clove oil and some of the steam then come off and are collected through the Liebig condenser, where they condense, and they are then collected in this round bottom flask here as a distillate in the form of an emulsion. So in our extraction of clove oil from cloves, we set up our apparatus as in the diagram on the previous slide. Then a given mass of cloves and a given volume of water are placed in a pear-shaped flask. The hot plate is switched on, and that allows steam to be generated, and the apparatus is just left for 40 minutes until around 50 centimetres cubed of our clove oil emulsion is produced. And during this 40 minutes, it is important to ensure that the steam trap is kept empty. So here's some sample exam questions that come up with this experiment. Why is it not possible to distill the clove oil directly from the cloves? And the reason for that is to avoid too high of a temperature, and which would cause the plant material or the cloves to decompose. The next question is, why is a long glass tube open at both ends usually placed in your steam generator? And that is to prevent a build-up of pressure within your steam generator, or to prevent the steam generator from exploding. What is the purpose of the steam trap? So the steam trap, it's to prevent your pear-shaped flask containing the cloves from filling with condensed steam or water. And the final question is, why is it better to use whole cloves rather than powdered cloves? And the reason for that is whole cloves contain more oil than powdered cloves. So the next part of the experiment is to isolate the eugenol from an emulsion of clove oil and water that has been collected during the extraction phase by steam distillation. Now this isolation will occur by a process called liquid-liquid extraction. So it's important to know what liquid-liquid extraction is. And liquid-liquid extraction is a technique in which two immiscible liquids are separated, so two liquids that don't mix, mix are separated using a solvent in which one of the components of the mixture has a higher solubility than the other. So for example, the organic compound is removed from the emulsion by dissolving the organic component in an organic solvent. And that is what we're going to do here. We're going to use cyclohexane to remove the eugenol from the emulsion. So this is just a basic diagram to show you what liquid extraction looks like. So basically you will have a separating funnel with your emulsion in it, and what you will do is you will pour in your organic solvent, which we will have cyclohexane. You'll seal the top and you'll shake it, and you will see 2 layers form, and you drain them accordingly, and we'll discuss that in greater detail in the next slide. What we're trying to isolate here in this experiment is eugenol, and eugenol has the following structure that we can see here, and this hexagon here in the middle with the circle is indicating the aromatic properties of the eugenol. So let's go through the steps of this experiment in greater detail. So it's liquid extraction, as we've already said. So our emulsion that we've collected from our extraction of the clove oil by steam distillation is placed into a separating funnel with 10 centimeters cubed of cyclohexane. The funnel is then sealed and it's shaken, and this is what we call washing with the organic solvent. So once this is shaken, we allow the aqueous layer and the organic layer to separate. And what we do is we drain the aqueous and organic layer into 2 separate conicals. So you'll have 2 conical flasks, one with the aqueous layer in it and one with the organic layer. Once we've done this process once, we take the contents of the aqueous conical flask and we repeat this washing twice. So you put the contents of your aqueous conical flask back into your funnel and you add 10 centimeters cubed of your cyclohexane and drain. So this only happens with the aqueous layer. You do not need to re-wash your organic layer once it has been collected in its conical flask. At the end of your 3 washings, your organic conical flask should now have 30 centimeters cubed of clove oil and cyclohexane. Now there may also be a small amount of water present because it's very difficult during the draining to get it exactly right, but that is okay because in the next step what we do is we add some anhydrous magnesium sulfate, and the reason we add anhydrous magnesium sulfate is it is a drying agent. So what it will do is it will fuse with any water droplets that are left in the organic conical flask, and it will cause the magnesium sulfate to clump together. So we can add the magnesium sulfate in excess because we want to remove all of the water that is left. So it doesn't matter if there's too much magnesium sulfate, it will just float to the bottom as a powder once all the water is gone. What you then need to do is you need to weigh a dry, empty conical flask and filter your organic solvent into it. So this removes the magnesium sulfate. So the organic conical is emptied into a new dry conical flask and the magnesium sulfate is removed. You do need to wash then with 10 more centimeters cubed of cyclohexane. So just wash the filter paper to ensure that any of the oil that might have been left behind is removed. So at this point there is now 40 centimeters cubed in your conical flask. Then what you do is you leave that in the fume hood overnight to allow your cyclohexane to evaporate. You then record the mass of your conical flask and you find the mass of the oil present by doing the mass of the empty conical flask. You take that away from the mass of the conical flask with the oil in it, and then you calculate your percentage yield. And we've done percentage yield calculations in the stoichiometry videos that you can find on the website. So in this experiment we added cyclohexane to Let's look at some sample questions that could come up in an exam based on this experiment. It asks, why is it necessary to use 3 portions of cyclohexane in the extraction process? And this is in order to extract the maximum amount of eugenol from the emulsion. The next question is what happens to the appearance of the emulsion with each washing? And with each washing, there's less and less of the eugenol left. So the emulsion becomes less milky or cloudy because the eugenol has been extracted and dissolving in the cyclohexane. So there is less of the eugenol present in each washing. What is the purpose of adding the magnesium sulfate? So the magnesium sulfate removes any excess water that is present that has not been removed during the organic washing process. What chemicals could be used as a drying agent instead of magnesium sulfate? They are sodium sulfate or calcium chloride. And the last question, give a reason why it is not advised to evaporate the cyclohexane using a Bunsen burner. It's because cyclohexane is flammable and excessive amounts of heat could actually cause the eugenol to boil off with the cyclohexane. So let's have a look at an exam question on steam distillation and liquid-liquid extraction. So the question says, diagram B shows a separating funnel in use in a liquid-liquid extraction of clove oil from an emulsion produced in a steam distillation of cloves. It asks us then, B part 1, what is an emulsion? So that's just simply our definition, which is that an emulsion is a dispersion of small droplets of one liquid in another liquid in which it is not soluble. Part 2 then says, name a suitable organic solvent that is used in liquid-liquid extraction of clove oil, and the answer to that is cyclohexane. Part 3 then says, other than wearing eye protection, gloves, a laboratory coat and tying back hair, state one safety precaution that should be taken when using a separating funnel. And the answer to that is to open the tap of the separating funnel regularly, and that is to release any pressure that may build up during the shaking process or the organic washing. So part 4 then says, how is clove oil isolated following the liquid-liquid extraction process? And the answer is that we allow the cyclohexane to evaporate overnight in a fume hood. Part 5 then is calculation. It says steam distillation, liquid-liquid extraction were used to isolate 0.15 centimetres cubed of clove oil from 5 grams of cloves. Calculate the percentage yield by mass of the clove oil. So the first thing there is it says you have to find the percentage yield by mass. So we know that we have 0.15 centimetres cubed of the clove oil. So we want to convert that to mass, and we know that density is equal to mass over volume. So that must mean that the mass is equal to the density by the volume. So the density, according to the question, is 1.05 grams per centimetre cubed, and that's multiplied by the volume, which is 0.15. So that means we have 0.1575 grams. And from there then you can do percentage yield equals actual yield over your theoretical yield. And we know that our actual yield is 0.1575 and that our theoretical yield is 5, and you multiply that by 100 and that gives us 3.15%. That's it for this video. Have a read over the learning intentions to make sure you understand everything we've gone through.